In this tutorial video, I want to show you how to find x-intercepts, otherwise known as zeros, on your graphing calculator. Again, you'll notice I have kind of side-by-side window going on here. On the left-hand side, I'm showing that I'm graphing the equation y equals x squared plus 3x minus 5, and I'm going through the work of finding the x-intercepts analytically or by hand. To find x-intercepts of any graph, when you have the equation, you set y to 0 and solve the resulting equation. In this case, the example I'm using is quadratic, so I'm using the quadratic formula instead of trying to factor. Quadratic formula always works. So I'm going through the process of using the quadratic formula here, and I come up with my two solutions, -3 plus or minus the square root of 29 all over 2. Here's -3 minus root 29 over 2. Here's -3 plus root 29 over 2. I'm going to show you two ways to check the work here. So first of all, in my y equals window, I have my equation y equals x squared plus 3x minus 5. And I think I should be able to do a zoom standard, zoom 6, and that should work. Again, seeing as how about -4 and around 1 were my x-intercepts, the standard zoom works pretty well here. Obviously, if I couldn't see my x-intercepts in the window, I would need to change the viewing window appropriately. But in this case, I can see the x-intercepts in that viewing window. Okay, so anyway, the easy way to check my work here is to just hit the trace button, and I'm going to type in this first x-intercept. I'm going to use parentheses for the numerator. I'm going to say -3 minus the root of 29, square root of 29. Let me close the root with a parenthesis and close the numerator. So there's everything in the numerator divided by 2. So take me tracing on the graph to that x value, and you can see there's the decimal approximation and that the y is 0. So there's my x-intercept. And I could do that for the other x-intercept as well. What I'm going to show you as a second technique is to, on the calculator, use what's called finding the zeros method. So above the trace key in blue is the calc menu. I'm going to do second trace, go to the calc menu, and number 2 you can see is 0. So I can either highlight number 2 and hit enter, or I can just punch the number 2 on the calculator. Now the calculator is going to ask me for 3 things. It's going to ask me for a left bound, a right bound, and a guess. Now I'm going to go ahead and move the blinking cursor off of the x-intercept for a second. Okay, so let's suppose we're going to find the other x-intercept. We already verified the -4 point whatever x-intercept. Let's find this other x-intercept. So let me move over here, and roughly the x-intercept right there. So to give it a left bound, I'm going to hit the left arrow a couple times so that I'm to the left on the x-axis of that intercept, and I'm going to hit enter. There's my left bound. And you notice the calculator puts a little arrow up here, and it says don't look any further left, look only in this direction. Now it wants a right bound, so I'm going to go back to the x-intercept and move to the right a couple places and hit enter. And again, notice the calculator puts another little arrow up here. So I've told the calculator only to look in this region on the x-axis. The x-intercept is somewhere in here. The third thing it wants is a guess. So I'm going to move my blinking cursor about as close to the x-intercept as I can get and hit enter as the guess. And it very quickly finds the 0, or the x-intercept, which is 1.1925824, and the y is 0. Now again, remember this is a decimal approximation. And down here you can see it's the decimal approximation to the exact solution. So the only drawback to using the 0 feature is you don't necessarily always find the exact value of the x-intercept, but it will give you a pretty good decimal approximation. And that is how you find x-intercepts or verify your work of finding x-intercepts using your graphing calculator.